going to be the assignment. Okay, so ensure you watch the previous video, then give this a try. All right. All right, limiting reactant. Now, normally, our limiting reactant or limiting reagent, it is the reactant that is used out first in a chemical what reaction. Okay, that's what limiting reagent is all about. Okay, now if you have two reactants, okay, let's say hydrogen and oxygen to give us probably H2O. Okay, now among these two, okay, between hydrogen and oxygen, one of them is being used out first. So the one that is being used out first between the two is the one that is known as the what, as the limiting reactant or limiting what, reagent. Now, when looking at the equation, okay, you can't just guess or just tell which of them is the limiting reagent. Though you can just use your normal unit, okay, yeah, I'm having two molecules of hydrogen, and yeah, I'm having just one molecule of oxygen. Definitely, the one that will be used out first should be oxygen. No, it's wrong. You don't do such. Okay, you must do some computation for you to know which of them is the limiting reagent. Okay, so we are going to be taking question on that since I've already taught you your mass relationship in chemical reaction. So using that same knowledge, that same idea, you'll be able to know this one. Then after this, you cannot take also theoretical yield. Theoretical yield is the maximum obtainable yield. Okay, and for you to determine your theoretical yield, you still work with the one limiting what reagent. Without your limiting reagent, you can't get the theoretical yield. Theoretical yield is the mass of the product that is being formed. Okay, that's what theoretical yield is all about. Then after that, we also take percentage yield. Our percentage yield is actual yield over theoretical yield. Okay, times 100 over 1 is expressed in what? In percentage. Okay, that is, if you want to test the efficiency of a reaction, okay, it's by using what? Percentage what? Yield. Okay, all right. Now let's take a question. A mixture of 3.50 grams of hydrogen and 26.0 grams of oxygen is made to react to form water. A. Which reactant is limiting? Which reactant is limiting? B. How many grams of water will be formed? How many grams of water will be formed? Then C. Which reactant will be left over? And D. how many gram of this reactant will be left over. All right. Now, we're going to work on this now. We were told that a mixture a mixture of 3.50 gram of hydrogen and 26.0 gram of oxygen is made to react to form water. Okay. Now, number one question says, which reactant is limited? B, how many gram of water will be formed? And C, which reactant will be left over? And D, how many gram of this reactant will be left over? That's the question. Okay, it's a very simple calculation. Okay, but before that, okay, you have to write out the reactions. Okay, remember, is your hydrogen and what? And oxygen that was react to form what? Water. So that means we have 2 molecules of hydrogen plus oxygen gas to form what? 2 molecules of what? Of water. Okay, the equation is balanced. Okay, now, but before that, we are given mass of hydrogen to be 26.0 gram and mass of oxygen to be, hydrogen is 3.50 gram. The oxygen 26.0 gram. Okay. All right. Now, what you are going to do when you are calculating the limiting reagent, listen up. You look for the number of mole of hydrogen. You look for the number of mole of oxygen. Okay. Now, the next step, you now calculate how many mole of hydrogen that was needed in the reaction to react with what? With oxygen gas. How many mole of hydrogen needed to react with what? Oxygen. Okay, and before that, first of all, you have to look for, to get the number of mole of hydrogen and number of mole of oxygen. Since you already have the masses, you have to look for the molar mass. Okay, remember, molar mass for hydrogen is 1 times 1, which gives us what? 1 gram per mole. Okay, and molar mass for oxygen, okay, oxygen is equals to, that is 60 times 2, that equals to 32 gram per mole. Okay, now this time around, to look for mole of hydrogen, remember, is mass over molar mass. What is the mass for hydrogen? 3.50 divided by, what's the molar mass of it? Is 1. 3.50 divided by 1, we still have 3.50 mole. So we've gotten the mole of hydrogen. We also look for the mole of oxygen. So mole of oxygen gas, oxygen. Oxygen is equal, that's mass over what? Molar mass. What was the mass for oxygen? We are giving 26.0. And what the molar mass for oxygen is 32. So that means our number of mole of oxygen, 26.0 divided by 32. We are going to have 0.8125 mole. So we now have the mole of hydrogen, and we now know the mole of what? Oxygen. Okay, so the next step now, you make use of the reaction. And the reaction, remember, I want to determine the limiting reagent. What is the limiting reagent? Okay, that is the reactant that is used on first, okay, in a reaction. Okay, that means you are working with the reactant side and not the product side. Okay, now this time around, we have 2H2 and what? An oxygen gas. These are to go about. How many mole of hydrogen do we have here? We have 2. Then how many mole of oxygen? Okay, oxygen here is 1. Okay, then the next step is that now that we know the mole of hydrogen and the mole of oxygen, okay, then we want to look for the number of mole of hydrogen that was needed to react with oxygen. Do we know? So we don't know. So what do? You call that place what? X. Okay, and we already know the number of mole of what? Oxygen, which is what? 0.8125. Then if we cross multiply S times 1, we have what? X. Then equals to 2 times 0.8125. So our S will be equals to 2 times 0.8125. So we're going to have 1.625 mole. If you observe, we now have 2 mole for what? For hydrogen. Now, this is the first mole. And the first mole is what? 3.50. And this is the second mole, which is what? 1.625. Now, to determine the limiting reagents now, you are working with these 2 mole. Now, you compare the 2 mole. Comparing the 2 mole, if you observe, our initial mole for hydrogen is 3.50. Okay, then why the final mole for hydrogen that we got is 1.625. Now, which one is bigger? That means the initial mole is bigger. What does it mean? It simply means that initially there was enough of hydrogen that was needed to react with what? With oxygen. Since the initial value is bigger than the final, okay, we are working with the word, the initial statement. It simply that initially there was what? There was enough of hydrogen that was needed to react with oxygen. Now, supposing what we have in the initial value was smaller than the final value, let's assume our initial value was like 0.125. If you compare 0.125 and 1.625, which one is bigger? It's 1.625. So if you want to put it in a statement, it simply means that initially there was not enough of hydrogen that was needed to react with oxygen. If there is not enough to react with this, it simply means that your hydrogen will be what? Will be the limiting reagent. Because the initial value here is smaller than the final value. Now, so from what we already have before, 3.50 is bigger than 1.625. It means that initially there was enough. Enough simply means that excess. There was excess of hydrogen that was needed to react with oxygen gas. Now, if there is excess of hydrogen, okay, it simply means that our oxygen becomes the limiting reagent, while the hydrogen becomes the what? The excess reagent. So with that, according to number, we are still dealing on the A part. So you can now conclude that our oxygen, or you can put it in a statement, okay, now, since there was enough of hydrogen needed to react with oxygen, therefore, you can conclude that oxygen, okay, is the limiting reagent. So from here, you can just go ahead that oxygen is the what? Is the limiting reagent. If oxygen is the limiting reagent, it simply means that your H2 becomes the what? The excess reagent. Okay, so you can copy that level to number 2. Alright, now that you now know how to determine the limiting reagent, the next question now was that, how many gram of water, okay, will be formed. Now, for you to calculate the mass of this water that will be formed, you have to work with the limiting what? Reagents. Okay, that's your theoretical yield. Theoretical yield is the maximum obtainable yield, that is the mass of the product that is being formed. Okay, now you are now asked, for you to determine your theoretical yield, you must work with the limiting reactant or limiting reagent. That means for you to determine the mass of this H2O, now the water that will be formed, you have to work with what? With limiting reagent and not hydrogen. I've already taught you mass relationship in chemical reaction, so that's what we are going to do now. Okay, so for the B part, all right. Let me just write down the value here. Okay, there's no need. If there's need, you still know. Okay. So for the B part, which is number 2, we are working with O2 and 2H2O. So here, you look for the molar mass of this. You look for the molar mass of this. You were given the mass of us, you don't know the mass of the cross multiply and have your answer. So to look for the molar mass of this, it says now 60 times 2, which was what? 32 grams per mole. Then why this? This 2 is affecting everything. So this is setting at H4 and O2. Hydrogen is 1 times 4, then plus what? Oxygen, 16 times 2. So 1 times 4 is 4 plus 32, which gives us 36 grams per mole. Okay, so since we are working with oxygen and 2H2O, okay, oxygen, the molar mass of this is 32 grams per mole. And the molar mass for water is how many? 36 grams per mole. Then what's the mass of oxygen? That's 26 grams. Then we don't know the mass for water. We call it what? X. So what do we do? Cross multiply. This time we have 32 grams per mole X. Then equals to this time we have 36 grams per mole, then times what? Times 26 grams. So gram per mole cancel out gram per mole. 32 times S, we have 32x. Then equals to 36 times 26. 36 times 26. So we have 96 grams. So to get our S, we divide both sides by 32. So our S will be equals to 96 divided by 32. So what are we going to have? We have 29.25. 29.25 grams. So this is the mass for what? For water, H2O. So that is for that. So the next question now, we are now asked, which reactants will be left over? You already know. The reactant that will be left over is what? Is hydrogen. So hydrogen will be left over. Then we are now asked, how many grams of this reactant will be left over? That is, how many grams of hydrogen will be left over? Okay, so copy this. Now, to do that, don't worry, I'm going to re-upload the video, okay, for the sake of those that are not online right now. So what we are going to do, to look for how many, okay, for the C part, our hydrogen will be left over. We are now asked, how many grams of this reactant will be left over? For you to work with that, you are still working with the limiting reagent. That is, the limiting reagent is very, very what important. Okay, in mass relationship and chemical reaction, it's very, very important. So this time around, so we are now working with 2H2 and what? And O2. We are asked, what is the mass of this that will be left over? Now, to do that, okay, you look for the molar mass for this, you look for the molar mass for this. Okay, you assume that you don't know the mass of this. Okay, you are given the mass for this. So once you get the mass, you subtract the initial mass or the final mass. From there, then you have your answer. So this is it. We are going to have 2 times 2 will give us 4 grams per mole. And here we are going to have, so this 2 times 2 will give us 4 grams per mole. So here we are going to have 60 times 2 will give us 32 grams per mole. So gram per mole is equivalent to gram per mole. So we are looking for the mass of hydrogen. I can call that place what? S. And we know the mass of oxygen to be what? 26.0 grams. So what do we do? Cross multiply. So if we cross multiply, so we are going to have this times this, we have 32 grams per mole, then X equals to 26.0 grams times 4 grams per mole. So gram per mole cancel out gram per mole. 32 times 7 give us 32x equals to 26 times 4. We give us 104 grams. So our F will be equal to 104 divided by 32. So what do we have? So we have 3.25 grams. Okay, it simply means that it was 3.25 grams that was made to react with what? With hydrogen. When hydrogen that was made to react with what? With oxygen. So it simply means that there's a leftover, there's a residue, okay, in the mass of the what? Of hydrogen. Now, for we to know that, how do we know? Now, to know the mass, the leftover mass of hydrogen, okay, you subtract this value from the initial value. It should be 3.50 minus 3.25. Do that. So we have 0.25 grams. It simply means that it is 0.25 gram mass that will be left over. Then why 3.25 gram was made to react, okay, with oxygen. So the leftover mass there is 0.25 gram. So we can copy that. All right, so let's proceed. All right, so let's proceed. So let's take this other question. So from here, they say the reaction two NH3 plus H2SO4 react to give us NH4 to then SO4. Is used in the commercial production of fertilizer if 22.7 gram NH3 and 54.8 gram H2SO4 are used. A. Which reactant is limiting? Which reactant is limiting? B. How many gram of NH4 2SO4 can be formed? C. Which reactants will be left over, and how many grams of it will be left? How many grams of it will be left? All right. Now, it's similar to what we've already done. Okay? Now, here, we are given 2 moles of ammonia. Okay? Then we're also giving our what? H2SO4, which is our sulfate, to form this product. Now, we are not told that the reaction is used in the commercial production of fertilizers. Okay? Then, if 22.7 gram ammonia and 54.8 gram hydrogen sulfate, tetrasulfuric acid are used, then which among these two is the limiting reagent? Now take note, in question like this, even though they didn't ask you to calculate limiting reagents, okay, you must calculate the limiting reagent, except if maybe the limiting reagent has been given to you. Except if maybe the limiting reagent has been given to you. But if the limiting reagent has not been given to you, and you are given a question like this, even though they didn't ask you to calculate the limiting reagent, they all went ahead. How many grams of this will be formed? There, you must calculate for what? Limiting reagent. Because you can't look for the mass of this product without you not knowing which of them is the limiting reagent. Because to determine the limit, your theoretical yield, okay, your theoretical yield is the mass of the product formed. And to determine the mass of the product formed, which is the maximum obtainable yield of the product, you must work with the what? With the limiting what? Reagent. Okay. Now this time around, what you are going to do, we are given the mass of what? Of ammonia. So our NH3, okay, we are giving it to be what? 22.7 grams. Okay, if you observe, the equation is balanced. Yeah, we have two molecules of nitrogen. Yeah, 2 is affecting here. So we have 2 nitrogen, and hydrogen. 2 times 3 is 6 plus 2, which is 8. So 2 times 4 is how many? 8. We have 1 sulfur, 4 oxygen, and 4 oxygen. So the equation is what is balanced. Okay. Now we also given our H2SO4 to be how many? That 54.8 grams. Remember, I said once you do your computation, what you do, you look for the mass, the number of mole of ammonia. You also look for the number of mole of H2SO4. Once you are done with that, you now calculate how many mole of ammonia. Now this is this first part, okay, that we are looking for. So when we are having our sulfate here, you calculate how many mole of what hydrogen sulfate needed to react with ammonia. Now it is what is starting the reaction that you are looking for. Okay, take note, it's your ammonia that is reacting with sulfate. It's not your sulfate that is reacting with what? With ammonia. It's not your hydrogen sulfate is reacting with ammonia. No, it is your ammonia that is reacting with what? With your tetrasulfacic acid. Now this time around, what you are going to do, first step, we look for the number of mole of this. To look for that, look for the molar mass for what? For ammonia, look for the molar mass of H2SO4. Nitrogen, so we have NH3. Okay, nitrogen is how many? Is 14 times 1. Then plus hydrogen is 1 times 3. So we have 14 plus 3. 14 plus 3 gives us what? 17 grams per mole. So to look for mole of what? Mole of NH3. Remember, it's mass over molar mass. Okay, so what's the mass of it? The mass, we are giving it to be 22.17 divided by 17. So 22.7 divided by 17. So we have 1.335. 335 mole. Then we also look for this H2SO4. Hydrogen is 1 times 2. Then plus sulfur is 32. So 32 times 1. Then hydrogen is 16. 16 times 4. So here we have 2 plus 32 plus 60 times 4 will give us 64. So let's add them together. If we add together, we are going to have 98 grams per mole. So we've gotten the molar mass for this now. So mole of H2SO4. Remember, it's mass over molar mass. So the mass of it is how many? Is 54.8 divided by 98. So 54.8 divided by 98 is going to give us 0.559 mole. So we've gotten mole of this and we've gotten mole of ammonia. So the next step then we work with the reaction. We are working with the reactant side. So here we have 2 NH3 and what? H2SO4. Now, how many mole of ammonia do we have here? We have 2. So 2 mole of ammonia. Equivalent to how many mole of hydrogen sulfate? Is 1. So we are looking for the number of mole of ammonia that is needed. We don't know. So we call it what? S. Then the number of mole of H2SO4 is how many? 0.559. What do? We cross multiply. 1 times S is still S equals to 2 times 0.559. So what are we going to have? So 2 times 0.559. So we are going to have 1.118 moles. Now if you observe, we now have 2 mole of ammonia. So this is the initial mole and this is the final mole. Now if you compare these 2 mole now, the initial and the final, which one is bigger? You see that the initial value is bigger than the final value. It simply means that initially there was enough of what? Of ammonia that was needed to react with what? With tetrasulfacic acid. If there is enough means excess. That means if there's excess, it simply means that ammonia is the excess or reagent, while your H2SO4 becomes the limiting reagent. So with this, you can conclude that since there is enough of of ammonia that was needed to react with H2SO4, therefore our H2SO4 is the limiting. Limiting reagent or reactant. So that's the first part of the question. So the next one will now ask, how many grams of your fertilizers can be formed? Now for you to know the mass of this that will be formed, you have to work with your limiting reagent, which is H2SO4. So copy this number 1 and let's proceed. Alright, so let's move to the next phase. Now that we know that our H2SO4 is the limiting, so for the B parts, we are now asked, how many grams of this can be formed? So then, we work with H2SO4 and NH4 2SO4. You look for the molar mass for this. You were given the mass for this, but we were not given the mass for this. Looking for the molar mass, this is taken as 1 times 2, then plus sulfur is 32 times 1, then plus oxygen is 16 times 4. So we give us 2 plus 32 plus 64, that is 98 grams per mole. So let's look for that of this. This is affecting everything. So this is taken as N2, H8, and SO4. Nitrogen is 14 times 2. Then plus oxygen 1 times, hydrogen is 1 times 8, plus sulfur 32 times 1, then oxygen 16 times 4. So here we have 2 plus 8, 2 times 14 is 28, plus 8, then plus 32, plus 64. Let's add up. 28 plus 8 plus 32 plus 64. So we have 132 grams per mole. So since we are working with H2SO4 and NH4 2SO4, so what the molar mass of this is 98 grams per mole. Then what the molar mass for this is 132 grams per mole. So gram per mole is equivalent to gram per mole. So we are looking for the mass of this. We don't know, call it X. In the question, we are giving mass of our H2SO4. We are told our H2SO4 is how many? 54.8 grams. So here we have 54.8 grams. So what do? Cross multiply. So this times 8, we have 98 grams per mole, then S equals to 132 grams per mole, then times 54.8 grams. So gram per mole cancel out gram per mole. So 98 times S, we have 98x. Then equals to 132. 132 times 54.8 grams. So we have 7233.6 grams. So to get a divide both side by 98, our S will be equal to 7233.6 grams, then divided by 98. So what are we going to have? So we have 73.81 grams. So can see now, we've gotten the mass for what? This is the mass of what? NH4 2SO4. So that's the mass of it. Okay, now that we've gotten this now, which is number 2. Number 3, we're now asked, which reactant will be left over? So since our H2SO4 is the limiting reagent, that means our NH3 becomes the what? The excess reagent, which is the leftover reagent. Okay, so now, So you can copy this. Let's move to the number 3. Then after that, we're now asked how many grams of it will be left over. Just the same approach we did before. It's very easy. Okay. Now let's move to the number 3. All right. For the C part, so our NH3 will be left over. Okay. Now for us to look for the mass that will be left over, now we work with the limiting reagent and this. So we have 2NH3 and H2SO4. Okay, look for molar mass for this and look for molar mass for this. These two is affecting everything. So this is written as N2A6. Okay, that is 14 times 2, then plus 1 times 6. So why for this? So here we have 28 plus 6. 28 plus 6 will give us what? 34 gram per mole. So why this one here we have 1 times 2 plus 32 times 1 plus 16 times 4. So here we have 2 plus 32 plus 64. We give us 98 gram per mole. So gram per mole is equivalent to gram per mole. So we are looking for the mass of what? Of ammonia. So we'll call it what? S. So what is the mass for H2SO4? That's 54.8 grams. So what do we do? Cross multiply. This times this we have 98 gram per mole. Then S equals to this times we have 34 gram per mole times 54.8 grams. So gram per mole cancel out gram per mole. 98 times S we have 98x equals to 34 times 54.8. So we are going to have 1863.2. Okay, so our S is going to give us 1863.2 grams divided by 98. So what do we have? So we have 90.01 grams. That means it was 19.01 grams that reacted with what? H2SO4 that was used. Okay, and remember the initial mass of ammonia given is 22. So since you used 19.01, where is the remaining one? That remaining one now is the leftover. So to get that leftover, I subtract this from this 22.7 grams. Okay, so what you now have left is the excess mass that was left. So you now say mass of or leftover mass of NH3 will now be 22.7 minus 19.01. Okay, so 22.7 minus 19.01. So it's going to give us 3.69. So our final answer there is going to give us 3.69 grams. So that means the leftover mass now is 3.69 grams. So you can copy this. Alright, so this is where we are going to stop for today. Okay, hopefully by tomorrow. Okay, yeah. No, I'm having edit tomorrow, so till on Wednesday. Okay, I'm going to have another class. That is going to be heat energy. Yeah, it's going to be heat energy. No, we've not really started any calculations on heat energy, so please try not to miss on Wednesday's class. Okay, so thank you very much for your time. So I'm going to try my possible best to re-upload the video so that for the sake of those that are not with us now, so that when they come online, okay, they will be able to watch the video again. Okay, so thank you very much for taking that time to be part of the class, and God bless you.